Hey guys, today we're going to talk about slope. Now we've all heard the term slope before and we've seen slopes. For example, like the mountain I have drawn here with the happy little trees at the bottom, or ski slopes, but we're going to talk about slopes in regard to math. And when we talk about slopes in regard to math, we are going to talk about the ratio of the change in y over the change in x. So we're going to have a fraction. And when we're talking about the change in y and the change in x, the slope on the line is going to be a constant number. It is not going to change. It is going to be constant throughout that particular line. And we use the letter m to note what's slope. So when we get into working with equations, linear equations, we'll use the letter m to stand for slope. There are 4 different types of slope. There is a positive slope, which has one value increasing and the other value increasing. And this is the most common type of slope that we look at. We usually look at that first quadrant when we're talking about graphs and things like that. Then we have a negative slope. A negative slope has an increasing value and then a decreasing value. So as one increases, the other decreases. We have a zero slope where the x values will be changing and it is the y value that will remain the same. And then we have an undefined slope. Undefined slope, the x value stays the same. The y value is the one that will be changing. And to help you remember which slopes correspond which, we have Mr. Slope over here. So we have our positive slope and our negative slope. We have our undefined slope and we have our zero slope. So now we're going to start finding slope. We're going to start with looking at a graphed line on the coordinate plane. And what we're going to do is we're going to use the line to help us determine what the slope will be. So if we look here, we have a line that is going through where the x and y lines meet together. Okay, so we can see that it goes through this coordinate here, and that coordinate there, and that coordinate there. The x and the y lines are meeting at those coordinates. And so what we're going to do is we're going to do something called rise over run. I'm going to determine, starting at one of the coordinates, I'm going to determine how many spaces or other coordinate numbers I have to go up, and then find out how many I have to go left or right to get to the next space or coordinate where the line goes through. So I'm going to start here at 0, 0, and I'm going to move up 1. And so in this case, I'm going to rise, and rise can be up or down. In this case, I have a positive slope, so it's going to be up. And then I'm going to go to the right once. And there you can see that I encounter the blue line at a coordinate. So I ran, so to speak, one time. And then again, if I wanted to check my slope, I can start at this point now and move up 1 and then over 1. Make that a little more clear. And then I can move up 1 and over 1 again, up 1 and over 1 again. So I'm showing that the slope in this is constant. So the slope here is going to be 1 over 1, or I can simplify that down to be simply 1. With our next example, we have a negative slope, and this one's nice because we have the coordinate points kind of made out for us, so that makes things a little easier in trying to find where the line goes through the coordinates. So if we look, I'm going to start at -1, 4. I'm going to start here. Okay, and in this case, I'm going to rise. Let me write rise here. going to rise 1, 2, 3, 4, 5. So rise 5. And since I am right here, I'm going to go 1 in the negative direction. So I'm going to run -1. That is going to make our slope 5 over -1, or I can simplify that down to -5. So if we have a whole number for a slope, we presume that we're going to be moving either right or left 1 space. So this is the number we will move either up or down, and we will presume that we're going to move over 1 left or right 1 space. And just to show you that the slope is constant, I can start here, I can move up 1, 2, 3, 4, 5, over 1 to the right, or excuse me, left. So there is my slope of -5, or -5 over 1. Our next example is also a negative slope, and again the points are made out for us. So I'm going to see how much I need to rise, and I'm going to start here. I'm going to move up 1, 2, 3, 4. Okay, so let me make that a little more clear for us here. 4. So I'm going to rise 4, and then I'm going to run 1, 2. Okay. And again, that's a negative, so I'm going to do that. So my slope in this case is 4 over -2, or I can simplify that down to simply -2 if I'd like. Okay. And again, if I wanted to see here, if I wanted to test if -2 worked, well, I can start here and go up 1, 2, over to the right 1, up 1, 2, over to the right 1. Okay. I can start here, go down 1, 2, over to the right 1. Down 1, 2, over to the right 1. Okay, so again, we go up or down with our rise, and our run goes left to right. Okay, so we have a -2 slope here, or 4 over -2. I think it's easier for us to have a simplified slope, because this is 2 over 1. Again, we don't need to write the 1 there, but again, we understand that we're going to be moving right or left 1 space. Okay, on this example, we have a positive slope. So let's see here, we're going to rise and then run. Okay, we're going to rise 1, 2, 3, and then we're going to run 1, 2, 3, 4, 5. Okay, so if we look at this slope, we have 3 over 5. Can't really do anything with that. Okay, we can simplify that. I do not recommend you make this a decimal. I think it's going to be much more difficult for you to figure out if it is in decimal form. Okay, just keep it as a fraction. And then if I wanted to double check, I could or go down 1, 2, 3, and then over to the left 1, 2, 3, 4, 5. So again, showing that that slope is constant. Okay. Okay, folks, we will be practicing this in class, and I will see you there. Oh,